The Crab Nebula is one of the brightest sources of high-energy radiation in the sky. Little wonder, it's the expanding remains of an exploded star, a supernova seen in the year 1054. Recently, astronomers using satellites sensitive to the highest energy form of light, gamma rays, have observed incredible flares in the nebula that theorists are hard-pressed to explain. The supernova left behind a magnetized neutron star, a pulsar. It's about the size of Washington, D.C., but it spins 30 times a second. Each rotation sweeps a lighthouse-like beam past us, creating a pulse of electromagnetic energy detectable across the spectrum. Here's what the sky looks like in high-energy gamma rays. The pulsar in the Crab Nebula is among the brightest sources. As the pulsar spins, its powerful magnetic field causes particles to flow. These currents ultimately light up the nebula. But as bright as the pulsar is in gamma rays, it isn't the source of the flares. NASA's Fermi Gamma Ray Space Telescope can look in between the pulsar's brilliant pulses to reveal the faint gamma rays from the underlying nebula. Yet several times since 2009, enormous flares have erupted somewhere within the nebula. The most powerful one to date lasted 6 days and made the nebula 30 times brighter than normal and 5 times brighter than previous flares. During the huge flare, astronomers also studied the crab with NASA's Chandra X-ray Observatory. Chandra's keen X-ray eye saw lots of activity, but none of it seems correlated to the superflare. This hints that whatever's causing the flare is happening within about a third of a light year from the pulsar. And rapid changes in the rise and fall of gamma rays imply that the emission region is very small, comparable in size to our solar system. Scientists say the gamma rays most likely arise from electrons moving near the speed of light, which emit gamma rays as they interact with magnetic fields. But to account for these flares, the electrons must have the highest energies ever seen in cosmic sources, 100 times higher than can be achieved in the most powerful particle accelerators on Earth. Even after 1,000 years, the heart of this shattered star still offers scientists glimpses of staggering energies and cutting-edge science.